So today we are going to start a topic TIR, total internal reflection, and what is internal reflection. Clear? So in this topic, so many students have confusion like what is the difference between internal reflection and total internal reflection. Clear? So see this
Yes,
very
sir.
carefully. This topic is very important. Many questions nowadays they are asking. So many application of TIR. This is really famous topic. TIR, total internal reflection, and so many application of TIR you will find. But before that, we should understand the meaning of this topic. So, what is the meaning of this topic? For example, first of all, understand this is medium, any medium. Clear? If I draw again, just a minute. This is any medium, and this medium is having refractive index of mu1. This medium is having the refractive index of mu2. Clear? Now this light, one light is going to incident like this, and it is having some certain angle of incidence. Then there is some refraction. There is some refraction will takes place, and this is R. This is what you have learned. Clear? Since mu1 is here, mu1 is more than mu2. Mu1 is dense, mu2 is rarer. This is what you have learned. And if I ask, apply Snell's law, then how you are writing? Mu1 sin I equal mu2 sin R. This is the way you are writing the Snell's law. Now, if I ask this question, again the same question I'm asking. See this diagram very carefully. This is the normal. This is the normal. If any light is incident like this, there is some refraction. This is the angle of incidence I. This is mu1. This is mu2. Angle of refraction. So if this I increases, then R also increases. If I again increase this value of I, then this R also increases. Clear? And if I again increase
Yes,
this
sir.
value of I, if I again increase this value of I, there is a condition, this refracted ray grazes the surface. Grazes means it becomes parallel to our refracting surface or boundary like this. Clear?
Yes, sir.
Understood up to this point? Any doubt? Tell me. See, I am increasing
No
this
doubt.
angle of incidence. Here angle of incidence is I. Here angle of incidence is I1. Here angle of incidence is different. You just take this I1. This is I2. So these are the angle of incidence. So what is the meaning of critical angle? Clear? What is TIR? Forget. This time, forget what is the meaning of TIR. First understand what is the meaning of critical angle. This term is very important. Critical, critical, critical angle. Clear? This term is very important in order to
Yes, sir.
understand this TIR, total internal reflection. Now, did you see one thing like if I am increasing the value of I2 is more than I1 and I1 is more than I. Here R, you can say this is R, this is R1, this is R2. So you can take this is R2, this is R1. So I can say directly this R2 is more than R1, R1 is more than R. Clear? So what is the
Yes, sir.
meaning of critical angle? Critical angle is the angle of incidence. Critical angle is the angle of incidence at which the refracted ray grazes the surface. Grazes the surface means it becomes parallel to the refracting surface. Clear? It is that value of angle of incidence where R becomes 90 degree. Clear? Did you see one thing like here?
Yes, sir.
See this final R2. It becomes 90. At certain angle of incidence, at certain angle of incidence, at certain angle of incidence, our refracted ray grazes. Grazes means it is going parallel to the boundary. This is the boundary or interface. Clear? So at this angle of incidence, the refracted ray, this is the refracted ray becomes parallel to the boundary like this. Then this angle is known as critical angle. This angle of incidence is known as critical angle. I just denote I is equal to C. So what is critical angle? It is that angle of incidence at which our refracted ray becomes parallel to the boundary. Clear? Now if you again increase this angle of incidence more
Sir,
than,
perpendicular, sir.
this is perpendicular. How much? 90 degree. So this angle of incidence is known as critical angle. This is critical angle. Critical angle. Any doubt? Now
No, sir.
if I again increase more than critical angle, if I increase angle of incidence more than critical angle, if I just increase only 1 degree, clear? For example, critical angle is 42 degree, clear? Then if I incident any light more than 40, 41 or 42, whatever is the critical angle, more than that, then what happen? It will come back. It will come back to the same medium. It will come back to the same medium. Now this process is known as TIR. This is known as TIR, total internal reflection, means whatever light you just entered or enter in the other medium, it is coming back totally. 100% light. 100% light is striking this boundary. This 100% light received. Clear? There is no wastage. Clear? If 100%
Yes, sir.
light is going to enter, it is 100% light is coming back to the same medium. This is known as reflection. This is what reflection na. Reflection means bouncing back of light within the same medium. So this angle, if you increase the angle of incidence more than the critical angle, for example, this theta, let us take this theta. This theta is more than critical angle of C. I is equal to C. If it is more than C, then TIR. You will see the TIR. Clear? This theta is the angle of incidence that is more than the critical angle. And at this critical angle, entire light becomes totally reflected to the same medium. Clear? This is known as total internal. Total means total. Total light. Internal means within the same medium reflection. Here it is internal. Here it is internally reflected. If you again increase the angle of incidence, you will see the same behavior. Clear? So
Yes.
below, if the light ray incident less than C, then you will see refraction. Clear? Like this. If theta is less than C, then you will see what? You will see such behavior like
No.
this.
Sir, I have a doubt, sir.
Yes.
I don't understand what will happen if theta is less than c.
Theta less than C means critical angle. For example, this is the at this light ray is parallel. I will denote by red. Clear? See, this is normal. Here angle of incidence is I. You just increase the angle of incidence, then you will see angle of refraction is also increasing. Clear? But at this angle of incidence, that is theta is equal to, you can say this angle of incidence is C. Clear? And at this angle of incidence, it is going to parallel to the boundary. Did you see? So if you increase again, if you again increase the angle of incidence, then it is coming back to the same medium. This is known as TIR. Clear?
Yes, sir.
Now, did you see like this is the reference line? If I indicate here reference line RL, so below C, below C, below C, did you see below C? These are the lines below C. You will see there is refraction takes place. See this diagram carefully. Below C, below critical angle, all these rays are going to incident at an angle of incident that is less than the critical angle. If the value of C, for example, if the value of C is 42 degree, and all these angles like I1 is less than 42 degree, means 40, 39, 38, like this, then there is some refraction takes place. There is refraction takes place. Clear? There is no TIR. But at critical angle, this reference line, see this incident ray. At critical angle, our refracted ray, this is the refracted ray, becomes becomes parallel to the boundary or refracting surface. In some books, they have written like this. Just a minute. Parallel to boundary. In some books, like in place of parallel, they are using the term wages. Clear? Tell me any doubt.
No doubt, sir.
Tell me any doubt. In case of TIR,
No, sir.
now after looking this diagram, which one is rarer medium, which one is denser? Tell me. This is mu1. If this is mu1, this is mu2. Then which one is rarer, which one is denser? This is denser. This is
Mu1 is
rarer.
denser and mu2 is rarer.
Clear?
Yes, sir.
Very nice. This mu1 is more than mu2. So for critical angle for TIR, mu1 must be more than mu2. Here mu1 must be greater than mu2. Simply, light ray must go from denser to rarer medium. Don't worry, I will write and you should write that time. Understand or not?
Yes, sir. Understood,
So
sir.
at critical angle, our refracted ray becomes parallel to the boundary. 90 degree, R becomes 90 degree. Clear? But below critical angle, all the incident ray that is going to incident, there is some refraction takes place. There is some R. There is some R value you will get for different angle of incidence. But at critical angle or more than critical angle, if you see more than critical angle, then entire light, entire light is coming back to the same medium like this. If I is more than critical angle, this process you will see. If this is 50 degree, this is 50 degree. Why is it so? Because it is reflection. Reflection in case of reflection, angle of incidence equal to angle of reflection. So this is
Reflection.
TIR. This is TIR. See, this 50 degree is more than critical angle. What is critical angle? 42 degree in the previous example. Clear? So 50 is more than 42. It means this light, if it is incident at this boundary, it will come back to the same medium. Clear?
Yes, sir.
Any doubt? Tell me.
No doubt, sir.
So now please write down. Write down. Angle of incidence. Write down. Angle of incidence in denser medium. Clear? All this angle. See, angle of incidence in denser medium means what? These angles like I1, C, these are the angle of incidence in denser medium. I'm talking about that. Clear? So angle of
Yes, sir.
incidence in denser medium for which light rays gauges along the surface. You can write R is equal to 90 degree. After refraction is known as critical angle. Any doubt?
No doubt, sir.
Is known as critical angle for the pair of medium. Pair of medium means pair of media. Plural of medium. For mu1 and mu2, this is the critical angle. If you change the media, then the critical angle will also change. Clear?
Yes, sir.
Now write down total internal reflection. Write down the heading total internal reflection. Write something about this. Write down whenever light traveling from denser to rarer, denser to rarer medium, comma, incident at angle greater than the critical angle of pair of medium or media, comma, it bounce back in the same medium. It bounce back into the same medium. This phenomena is known as total internal reflection. Any doubt?
No, sir.
Clear? Now write down what are the conditions. Write down conditions for TIR. Right, this is very important. So what is the condition like after looking this figure? What is the condition? First condition is, write down, light must travel from denser to rarer medium. First condition. Next condition, angle of incidence is greater than critical angle. I subscript C or C. You can write C. Okay, I just denote this critical angle by C. Here, these are the basic condition, and I will show you like all the application of this TIR. But make sure, I will say one thing to you. Just see this application, but don't ask any much don't go in depth. Simply understand what are the application of TIR. First application is brilliance of diamond. Did you see like diamonds are brilliance of diamond? Diamonds are sparkling. Why diamonds are sparkling? The reason is whenever any light is incident in a diamond, it is internally reflected. This light ray never ever come back to the same medium. Internally, this white light enter and it is internally reflected. Clear? And I will explain what is prism later. Then you will see when light is entered in this diamond, this glassy surface, there is some dispersion also. This you will see the band of 7 colors. Then you will see blue light is coming from this point, blue. Here green light is coming, red light. So diamond is sparkling. So sparkling of diamond is because of TIR. You can see this light. This light once enter, it is again reflected into the same medium. Is it so?
Yes,
Clear?
sir.
In a similar way, this is known as optical fiber. Nowadays, like most of the wireless communication, did you see like modem in your home? In that modem, like, did you see like this some line? Like, did you see like this glass fiber, small line? Did you see like one cable
Yes, sir.
at
Yes,
your
sir.
home? Nowadays, Jio are providing this cable, like very fine cable. This cable, plastic, some material is there. Inside this, there is some glass. This is some glass. If you open that, there is some glassy material. Clear? I will just draw one layer like this. Clear? You can see this.
Yes, sir.
2 layers. One layer outside, one layer inside. So outside layer is some plastic or something else, some other material, and inside is some glass. You can see here. This outer layer is known as core, inner core. Did you see this? Cladding. This cladding, forget what is cladding and these things. It is not in your syllabus. Simply understand what is the meaning of that. This optical fiber, once light entered at the core. This inner layer is known as core. This is core. Clear? An outer layer. This outer layer is cladding. Clear?
Yes, sir.
So inner layer is core. Then outer, whatever plastic is cladding. Inner is glass, outer is cladding. So the refractive index of this cladding is, let us suppose, mu2, and refractive index of this core is mu1. So once light is going to strike like this, it should go from core to cladding. See, this is cladding and this is core. This is cladding material, outer layer. This is cladding. Clear? This is cladding. Clear? And this is
Yes,
core.
sir.
So once light entered like this. Then the cladding, it is going from core is having refractive index of mu1. Let us suppose mu1. Cladding is having refractive index of mu2. Then this mu1 must be more than mu2. If it is so, like if mu1 is more than mu2, then it is going from denser to rarer. Clear? So they will set certain angle when light is going to incident. At certain angle, it always come back to the same medium. TIR. Again TIR. Again TIR. Like this. Why TIR is happening here? Because they just fix the value of this mu1 and mu2, core and cladding. Because of that, any signal is going to enter in this optical fiber. This one fiber. Here, if any light entered, then 100% signal like is going to enter from this point, then 100% signal is received at your home. It means what? If, for example, from the geo station, if they are providing a speed from your modem, like if the speed is 30 Mbps, what is that? Mbps or what? Megabyte per second. Then you will receive at your in your laptop or in your mobile how much? 30 Mbps. Reason is because of this TIR. If 100% signal is going to enter, then 100% you will receive. That is why this optical fiber, because of that you will receive very fast internet. Fast internet. Reason of fast internet is only TIR. Clear? So
Yes, sir.
and in the operation, like most of the operations nowadays, they are taking help of optical fiber. It is very fine thread. Optical fibers are very fine thread. Here in operation in medical field is very, like you can say, lot of use in medical field, in mining industry. Clear? They are using this optical
Okay.
fiber in signals communication. They are using optical fiber. So if you want to see optical fiber, I can show you. Just a minute. Optical fiber. It will be more clear then. Just a minute. Did you see this? This fine threads.
Yes, sir.
This is known as optical fiber. These fine threads. I just show you only one thread, one optical fiber. There are millions of optical fiber. Clear? This is known as, see this. This is optical fiber. Red. This is optical fiber. Clear? Any doubt?
No, sir.
If you have any doubt, you can ask me anytime. Clear? So optical
Yes, sir.
fibers are very important in communication. It is highly important. Now next is mirage. This mirage, what is this mirage? Mirage means illusion. For example, tree is here, and you will see the inverted image of tree. Inverted image of tree. Then it is inverted only because there is some water. Because in water only image is formed. So mirage is illusion in most of the desert area in hot, like hot weather. In hot weather, tell me, like our floor is very hot. So
Yes, sir.
this is what? This is rarer, and top layer is denser. Clear? The surface is hot. The sand is very hot. Then temperature is very high. If temperature is very high, the air molecules are far spread, like they are spread very much. If you increase the temperature, medium becomes rarer. Clear? If you decrease the temperature, all the molecules comes very close. Then it becomes denser. So in the hotter days, like in hot condition, the you see the different layers of, for example, this is the tree. Clear? Now, if anyone, like, if I show you, for example, this is the person who is standing here, and there is, he is moving in a desert area. Then there is layer of air layer, layers of air. So many layers of air is there, present there. Clear? These are the layers of atmospheric air or layers of air. Understood?
Yes, sir.
Now, this tree, this tree is looking like this. So from here, this is denser. Denser, like if I ask you, this is denser, more dense, less dense, very less. This is more rarest, or I can say highly rare, medium. This bottom layer is more rarest. So if you are moving from top to bottom, then medium becomes more rarer. Clear? So how many boundaries are here? These are the boundaries. And if light is coming from the tree like this, then it is going from denser to rarer. It will bend away from the normal. When light is going from denser to rare, it will going away from the normal like this. Again, light is going from denser to rarer, because when you are going from top to down, uh, density medium becomes rarer. Clear? Because temperature is very high at the bottom surface. Clear? So here medium is more dense, less dense, very less, very less, very less. It is more rarest here. So light is going from denser to rarer medium. So what is TIR when light is going from denser to rarer medium? This is the condition of TIR. Clear? So there is
Yes.
a certain layer, you will see again it is going away from the normal. At certain layer, there is some TIR will takes place. TIR will takes place. Clear? Here TIR happen because light is going from denser to rarer at certain condition, at certain layer. Because this mu here, if I ask you for this layer, different refractive index for this layer, different refractive index for every layer. If I ask from top to bottom, this mu value gonna be increasing, not increasing, decreasing. So when mu is decreasing, it means medium become denser or rarer?
Rarer.
Rarer. So at this point, TIR happen. So tell me, these are, I just draw only one ray, but there will be many rays. Here, not only one
Yes,
ray
sir.
from this tree, so many rays are coming like this, and it is going to strike into the eye of this human being. And as per the observer, light travel in a straight line. Then according to him, he will think these two rays are coming from this point, and he will see this image. Which image? What type of image he will see? Like this, upside down. Clear?
Yes, sir.
Why is it so? Because for the observer, he doesn't know. Tree is very far in the desert area. Then from that tree, light is coming, and TIR happen. And in the eye of this observer, these rays are going to incident or striking. Did you see? Did you see this diagram carefully? So these rays are going to strike. Then according to him, he will think these rays are coming from. He will drag it back, because according to us, always light travel in a straight line. He has no idea from where this light is coming. Clear? Where is the tree? He doesn't know. But he will see. He will not see this. He will not see this. He will see this only. According to him, he will see there is a inverted image of tree. And and he will think there is some water, because in water only this happen. If you see any trees nearby water, you will see the image of that tree in a water. Did you see this? Then he will think, the person in this desert area, he will think there is some water here, and this is the illusion. There is no water. Clear? Any doubt? This is known as
No, sir.
mirage. Mirage means illusion. This diagram is very, very important. I think it will clear all your doubt. Any problem? Tell me. This
No,
is known
sir.
as, so this mirage. Mirage is mainly you will find in the desert area where temperature is very, very high. But one is looming like this. You will find this in your Chennai, like in Tamil Nadu, you will find this looming. If you go in a sea nearby sea, then you will find looming. Looming simply means this is the object. Clear? Now, in the coldest area, if you are going in a coldest area, then bottommost layer, this bottommost layer is more dense. Here, density is more dense. And if you go above, density becomes medium becomes rarest. So cold air is in the, because cold air is little bit heavy, then it will move in the bottom side. Then rarer medium, warm air is lifted up, then it is going in the top layer. Here, like convection current. Did you see in your seventh class? Do you have learned convection current? So in convection,
Yes.
cold water is coming downside and hotter water is going up. Then there is a convection current is, you will see, like land breeze, sea breeze. In the same way, in the looming is, you will find looming in the coldest region. In coldest region, this top layer density, this medium is becoming more rarest as you are going from bottom to top. So I can write here, if you are going from bottom to top, just I have written here, this mu value gonna be decreasing. Then medium become rarest when you are going above. Here, I
Yes,
will
sir.
share one more link. I think it is about to finish. So did you I will explain, don't worry, looming once again. So I think I will stop sharing my screen. Any doubt, tell me.
No doubt, sir.
Okay, okay. I will share one more link, just join from there. Okay. Tell me any doubt to you.
Sir, can
If
you
you know,
explain mirage alone one more time, sir? The
yeah, I will
formation.
explain. I will explain. Mirage, at which point I is stuck? See,
Uh,
Mirage. Mirage is mainly found in the desert area where temperature is very, very high. Clear? So in desert area like nomads, you have learned they are moving in the desert area and they are thirsty. Clear? So while moving in the desert area, there is some illusion happen. They thought like there is some water nearby. And how do you understand like water is there or not? Clear? If you see any trees, coconut trees nearby river, then you will see the inverted image of those coconut trees in the water. Clear? So in the desert area, if anyone find the inverted image of trees, then he will think there is some water there. That is the illusion. Now what is mirage? I will explain. In case of mirage, the temperature of, here, just see this very, very carefully. These are the layers of air. Here temperature is on increasing the temperature, medium becomes more dense. Mu decreases. Clear? If the temperature of bottommost layer is very high, here temperature is very high, T is very high. Clear? Then if T is very high, then mu will be very, very less. Here temperature is very less because on moving down, on moving above, temperature goes down. Here temperature of layer is air layer, atmospheric air. Clear? Here temperature is very, very less, or temperature is less as compared to bottommost layer. So here mu is very, very high. in between temperature will vary. For example, here temperature is 100, you can take 50 degrees Celsius. Then here you will see the temperature is 20 degrees Celsius. Then in between that you will find some variation of temperature 50, 40, 40, 50, 40, 30, 35, like this. Clear? Then you will see at every boundary here different refractive index, here different value of mu, here different value of mu, here different value of mu, here different value of mu. Now here mu is high, is in topest layer mu is very high. It means that this is denser medium. Clear? Here mu is very less, so this is rarest. Here temperature is 50 degrees Celsius, but in between that, here temperature is different, here temperature is different, here temperature is different. So different value of mu, but here more dense, less dense, very less dense, very less dense. So this value of mu goes, it is about to increase. This arrow sign is showing like this, sorry, decreasing. This is showing like decreasing. This mu decreasing as you are going down in the desert area, or at a place where temperature is very high. Clear? So
Yes, sir.
understood up to this point. Now if this tree is remote, if this tree is very far, or at a remote place, this tree is very far away. Clear? But you are not able to see where is tree, but you are moving on this sand. Clear? You are moving on the sand, how will I explain? You are moving on a road or sand. Then you will see the inverted image of this. For example, this light is coming from this tree. This tree light is coming from this tree. Then there is some refraction takes place. Again refraction will takes place like this. From the tree light is coming like this, from denser to rarer, because topest is denser. If you go down, medium becomes rarer. So denser to rarer, light is going away from the normal like this. Again it is like this, away from the normal. Clear? Again it is away from the normal, but at this point, this light is striking at this certain angle of incidence that is more than critical angle. Then there is some TIR will happen at certain layer. Clear? Then
Yes, sir.
these rays are coming from the tree. I just show only one. These rays are coming from the tree. Now who is standing here? Here some person is standing, and in the eye of this person, these rays are entered. These rays are entered. Now tell me, there will be many rays from this tree that is entered in the eye of this person. Then this person will think. Then this person will think what? What he will think? He will take those
The
rays
thing
to
is
the back.
inverted.
Then he will see the inverted, like this image of this tree. This is known as mirage. Same image he will see here. Now this is the bottommost sand. Here sand is sand. Clear? And he will see what? This tree inverted down. When this is inverted down, it means what? There is some water here. Then only there is chances that inverted image formed. Here there is some water. Then only this inverted image of this tree is taking place. Any doubt?
No, sir.
Then this person will think there is water here. There is water. In the water only the image can be formed. Then he will think water will be there. When he touch, he find this is illusion. This is mirage. There is no water. He is looking this is happening. Why in desert this is happening? Because of TIR. At this point, TIR happen. TIR. So mirage. Mirage mainly you will find in the desert area or where temperature is very, very high. Clear? Now what is, see this, you can see this pic. Is it visible?
Yes, sir. It's visible.
You can see this coconut or whatever tree is it. Cooler air, cool air, hot surface. Clear? So light is coming from the tree. It is what? TIR happen. Go clear? It is reflecting
Yes, sir.
again TIR. Then according to him, this light is coming from, he will think light is coming from this point. Then he will see the inverted image of this tree and he find there is some water, but there is no water. This is known as mirage. Mirage, in case of mirage, the hottest, the surface is hot. Surface is hot means temperature is high. Temperature is high means medium is rarest. But the all, but if you are going from bottom to top, like from the surface to toppest layer of the air, then toppest layer there is, you will find cool air. That is denser because if air is cool means temperature is low. Temperature is low means medium is denser. Clear? So
Yes, sir.
understood. This is known as mirage. But nobody is going to ask. They will ask simply the question, what is mirage? In such question, they will never ask what is mirage. First of all, but application of mirage they can ask. If they are asking, you can write in your own way. So mirage understood.
Yes, sir. Understood, sir.
So you can see here also like this is mirage. See from this TIR happen here. Where TIR happen? There here TIR happen. Light is going to the same medium. He will think light is coming from here. Hot air, cool air. Hot air at the bottom. This is the bottom surface. Bottom. Toppest. This is toppest. Cool air. In the top, cool air will be there. Here, if temperature is high, then value of mu is very, very less. Here temperature is low, then mu is very, very high.
Okay.
If mu is very, very less, medium is rarest. Now what is looming? Looming. So see very, very carefully. Looming is mainly you will find in the coldest region like Ladakh. Here, like in the case of nearby ship, nearby sea. So in the sea, like did you observe like when you are moving in a sea area, then you are feeling very, very okay. Like you are feeling good. Why? Because you will find the cold, like you will find everywhere cold air nearby the sea. That is why you are feeling okay. So if you see, for example, this is any ship. This is the ship, and this is any one. Clear? Now this ship and the bottommost layer is denser. Topest is rarer. So when light is going from denser to rare, did you see like again refraction at a certain point? At a certain point, the entire light is going to TIR
The
happen.
observation.
TIR. Then he will see this light is coming to his eyes from where? When you drag it back, the ship is not here. He will think ship is here, but that is the virtual image of the ship. Clear? So
Yes, sir.
this is known as horizon. Horizon. This is known as horizon. You know what is horizon?
Yes, sir.
In
Between the place where land and sea meets,
yes,
seems
yes,
appears to me.
yes. This ship, which is at the land, but he will think this ship is little bit hang in the air, hanging in the air. The ship is hanging in the air. You can see like when you are going to a beach, then watch some ships or harbor. You will see in a harbor point, you will just go and see the ships. You will see the ship. Actually, it is at the horizon. But virtual image you will see. You never see this actual image. You never see this thing. You always see what? This virtual image of the ship. According to you, the ship is hanging in the air, but it is not. Clear? So it is known as looming. Looming is, in case of looming, just reverse of mirage. In case of mirage, bottommost layer is more rarest. But in case of looming, bottommost layer is more dense. More dense means temperature is very low. Cold air is flowing in the bottommost area, while warm air is moving in the toppest area. That is why you are feeling cool. Here, in case of
Yes.
when you are on the land, like in Chennai, when you are living in a land surface, when you are moving on the road, then roads are very, very hot. Temperature is very high there. Clear? Temperature is very high there. And in the sea, the cool air, clear, their temperature is very low as compared to the land. Clear? So in the sea, like here, cool air is present, denser medium. But in case of roads, on the roads, there is a rarer medium. Clear? Then you will see like you are not feeling okay there. But when you reach the sea, you are feeling okay. Why? Reason is you will find this. Clear? There is
Yes, sir.
sea bridge, land bridge. You understand what is land bridge, sea bridge?
Yes, sir.
Clear? So land bridge, sea bridge, you will notice, and if you understand that, then there is nothing to worry while understanding this looming topic. Clear? Looming caused by total internal reflection. Clear? So there are mainly three application. One is looming, one is sparkling of diamond, and this is also the mirage and optical fiber. These are the application of what? TIR, total internal
TIR.
reflection. Now see this, here also TIR happen. Why? See, from this tree, two light rays are coming like this. Here, when it is striking, there is here TIR happen, and this light is going back to the same medium. Clear? Again TIR happen here. TIR simply means when light strike the boundary, it is coming back to the same medium. Did you see like it is coming back to the same medium? Here also
Yes,
it
sir.
is coming back to the same medium. TIR happen here. Now there is no TIR because this is 90 degree. 90 degree angle of incidence means there is no refraction. It is going in a straight line. Then you will see this tree. It is like this, but you will see the image will be like this. Clear? So
Yes, sir.
total internal reflection causing a light ray to bend through 180 degree in a 45-degree prism. Now what is 45-degree prism? When I started this lecture prism, then you will understand there. Clear? Any doubt? Tell me.
No, sir.
So application
No
part is
doubt,
clear.
sir.
Application part is clear. In the next lecture, I will explain all the numericals regarding this topic. Clear? Tell me any doubt.
Yes, sir. No doubt, sir.
Okay, clear. This topic is clear like critical angle. So critical angle, it is that angle of incidence
Yes, sir.
at which light is reaching the boundary. If you increase more than
90
critical
degrees.
angle, it is coming back to the same. That is known as TIR, total internal reflection. When light becomes totally internally reflected, then that is known as TIR. There are basically two conditions. One condition is the light should go from denser to rarer medium. Second condition is what? Tell me.
Angle of incidence should be greater than TIR.
Angle of incidence must be greater than the critical angle. Clear? Critical angle. For example, critical angle is 42 degree. Clear? If light ray
Yes.
incident at 30 degree, then there is refraction. Clear? Now, what is one thing like I would like to explain? Let me explain this. What is TIR and internal reflection? What is the meaning of simply internal reflection? See this very, very carefully. TIR means total internal reflection means entire light. Entire light is internally reflected, but in case of simply the meaning of the term internal reflection, see this light is striking the surface, some portion will refract, some portion will refract. This is angle of refraction. Now, but some portion, some little bit, only 1-2% or 5% light reflect. So this entire process is known as internal reflection. Simply internal reflection. We never say TIR. Simply this is known as internal reflection. Clear? But
Yes, sir.
in case of TIR, this is known as TIR. This is TIR. Total internal reflection. Clear?
Yes, sir.
Internal reflection, some portion will go for refraction, some portion is going to reflect. That is known as internal reflection. If 100% light is coming, then around 2%, 2 to 5% light is going to reflect, and around 97 or 97% or less than 95 to 97% light is going to refract. This is known as internal reflection. Any doubt?
No doubt, sir.
Okay. So today's lecture I will stop here. If you have any doubt, please ask me anytime. Okay?
Yes, sir.
Take care. Okay, tomorrow will be your holidays. Tomorrow will be no class. And on Monday, I will conduct one periodic test. Okay? Syllabus is magnification. Till now, whatever I have explained, I will conduct one test on Monday. Around 5 questions I
Yes.
will ask regarding the mirror, or maybe from lens. Not from lens, like apparent and real depth. And today's topic, I will not ask any numerical because I just explained the concept. I didn't discuss the numerical. Clear? So Monday will be your test. So be ready for that. Clear? So 7 o'clock timing is okay, or below that? Before 7?
7 o'clock is okay, sir.
7
Anything
o'clock.
is okay.
7 o'clock is okay? Hello?
Yes, sir. Monday anytime is okay, sir.
Monday?
Anytime is okay.
Okay, anytime is okay. Then prepare well. I will conduct anytime. I will explain. Okay, I will tell when I will conduct your test. I will tell. Okay, no need to worry. Again, say totally clear.
Yes, sir.
Clear?
Yes, sir. Totally clear, sir. Yes,
Yes.
sir.
Be confident. Okay. Okay, I will stop this lecture. Good night. Good night. Bye.
Thank you, sir. Good night, sir.
Write down the question. Find the critical angle for air and glass. Glass is having the refractive index of 1.5. Find the critical angle for air and glass interface. Here, first question. Solve this. Easy question, okay? What is the formula? Simply, first of all, draw the figure. Give me the answer. How much?
Sir, I don't think we went through the formula, sir.
What?
Sir, I don't think we went through the formula.
Formula is like, just a minute. I will discuss the concept first. Maybe like I discuss or not. This is a glass slab. Air and glass interface. This is our glass. Glass. It is having the refractive index of how much? 1.5. This is air molecules. This is the interface of glass and air. The critical angle they are saying. Critical angle is the angle of incidence. Angle of incidence the value of that angle of incidence at which light ray, refracted ray makes an angle of 90 degree with the normal, like this. Apply Snell's law. Sin I is equal to 1 into sin 90. Clear?
Yes, sir.
Sin I how much? Sin 91 mu g 1.5 2 by 3. This sin I is how much? I will be sin inverse 2 by 3. Okay, inverse trigonometry like ask like to teach. Inverse trigonometry is very important. Okay. I is this, forget
Yes,
this.
sir.
Okay. Forget this. Sin I is equal to 2 by 3. So this angle is critical angle. You can write IC. I is equal to IC. Okay, you can write. This is critical angle. What I am asking. Here at this angle, this light ray grazing the surface. Clear?
Yes, sir.
If any angle is more than this, IC. Clear? This I is equal to IC. IC means IC means critical angle. If any angle is more than IC, then it will, light ray will come back to the same medium. Clear? Now next question, write down.
Yes, sir.
Complete the
Sir, can you show the previous answers?
previous answer is sin inverse 2 by 3.
Yes, sir.
Any doubt?
No doubt, sir.
Now write down the next question. Complete the path of ray. Complete the path of ray. If the critical angle is 42 degree. If the critical angle is 42 degree. Now I will draw the figure. Question is complete the path of ray if the critical angle is 42 degree. See, light is striking like this. Can it complete the circuit? I will solve. Okay, no worry. This is 42 degree. This is 90. As per the question, this quadrant, clear quadrant. Understood? Now I want to complete the path of, I want to know this light ray is going, will, like it will pass or not. In which direction it will move. I want to know the path. Clear? So how to solve this? You see it very, very carefully.
Yes, sir.
This is quadrant, 90 degree. 42 degree is not a angle of incidence. Clear? Angle of incidence means it is the angle made by the incident ray. This is the incident ray with the normal. This is angle of incidence. Critical angle is how much? 42 degree. Clear? If this is 42 degree, then how much this? 48.
48 degree.
Now, sir, tell me, if the critical angle of this glass slab or whatever else, this material, for this material, critical angle is 42 degree. 42 degree means what? Hello? Just a minute. Some technical glitch.
No, sir.
Should I explain once more this question?
No, sir, I understood, sir.
Very easy question, okay? This is a very easy question. Next question. You need to complete the path of ray. Again, I'm asking one more question. Draw this. Now light is striking like this. This is 45. This is 45. Right angle triangle. Critical angle is 42 degree here. C is critical angle. Can you draw the path?
Yes, sir.
Please draw. I am also drawing. Is it so? 45 degree more than critical angle. Again, come back to the same medium. This angle is also 45 degree. Right angle triangle. This all?
Sir, I'm not getting the answer, sir.
See this carefully. Again, I am solving. Okay. No need to worry. Critical angle is 42 degree. Clear? Critical angle is 42 degree. This is the light ray. Clear? Now, see this light is striking at 90 degree. 90 degree incidence. Then there is no refraction. It is going straight from this boundary. Clear?
Yes, sir.
Now, this is 45. This is 45. This is 90. Now, I want to know, first of all, I will draw the normal. If this is 45, this is 90, this is also 45. This is how much? This is also 45 because total is 90. Mathematics. Tell me. Any doubt? See, this is
Sir,
the incident ray.
how can we assume that the light ray is normal, sir?
See, this is normal incidence here, like this. It is not inclined.
Sometimes it can be oblique also, right, sir? How can we assume that it's normal, sir?
See, surface. Normal incidence means this. This is normal. This is a boundary. See this boundary. This boundary. This is not normal incidence. You will draw the normal. It is making some angle with the normal. It is not a normal incidence. But once this light is striking like this, normal to the surface, like this. From this surface, this is a surface striking 90 degree. Then you will draw the normal here. What is the angle of incidence?
90 degrees.
Here angle of incidence, not 90 degree. This is not this oblique incidence. This is oblique. Here this is normal incidence. Understood?
Yes, sir.
So if angle of incidence is 0, then apply Snell's law. Angle of refraction will also be 0. You can apply mu into sin I, mu1 sin I equal to mu2 sin R. Sin I is 0 because angle of sin 0 is 0. Then angle of refraction will also be 0. Clear?
Yes, sir.
Now see, now this is normal incidence. Normal incidence means if light is striking like this is our surface. This is any material, glass slab. Clear? If light is striking at normal incidence like this, there is no refraction, it will go straight. There is no refraction, again it is striking. But see, now this is not a normal incidence. You will draw the normal. This is 90. It is making some angle with the normal. This is not a normal incidence. Clear? Understood?
Yes, sir.
Always draw the normal. Normal is perpendicular to the surface. Wherever our light is striking, always draw the normal. Now tell me, this is 45, this is 90. Then how much this?
45.
90, 45, this is also 45. This total is 90. This is also 45. Clear?
Yes, sir.
Now what is the critical angle? 42
42.
degree. Now light is striking less than critical angle, more than critical angle.
Less than critical angle.
Again see, what is the
But I is
critical
0.
angle? Light is striking at what angle? At this surface.
40, 45 degrees.
45. 45 is more than, I is more than 42. Light is striking at more than critical angle. Then it will come back to the same medium like this. It is going like this. Previous topic, did you revise critical angle topic?
Yes, sir. But now I'm feeling confused.
Why?
There, incident ray striking and
See, light is going from denser to rarer. This is denser medium. This is rarer medium. Clear? Then light is going from denser to rarer. And this angle of incidence with the normal is more than the critical angle. If it is equal to critical angle, it will go like this. It will go like this, grazing the surface like this. But now it is more than critical angle, it is 42 degree. Then internal reflection will take place. Here TIR will happen.
yes, sir. Now I understood, sir.
Understood?
Yes,
Always
sir.
see the angle of incidence. If it is more than, then internal, this is TIR. Total internal reflection. Total reflection angle of incidence is equal to the angle of reflection. Now this is 45. Clear? Now this light 45, 45. Then again it is striking this surface. Now see this, at what angle it is striking the surface? 90 degree. Clear? Then if it is
Yes, sir.
striking at 90 degree, then there is no refraction. Clear? It will go straight. Any doubt?
No, sir.
Tell me.
No
Now
doubt,
next
sir.
question you will solve. Next question you will solve. Okay. Complete the path of ray. Again I am giving one more question. This is 30 degree. Clear? This is
Yes, sir.
60 degree. This is angle sum of triangle 90 degree. Now again I am asking the same question. Critical angle is 42 degree. Complete. Now see, it is normal incidence. It is going straight. Clear? See, this is 30. This is how much this?
60.
Very good. Now always draw. After coming here, you will draw the normal. This is normal. Now check what is the angle between normal and the incident ray. How much this? Tell me.
100. 45, sir.
Forget 45. How is it 45? This is 90. Normal. Total is 90. This is 90. This is 90. How much this?
30.
Ah, very nice. This is 30 degree. This is normal. Light is going from denser to rarer. Now check. What is the angle of incidence?
30 degree.
30. Is 30 more than, is I is more than IC or less than IC?
Less.
Less. If it is less, then there is no TIR. If this is 30 degree, what is the angle in, then it will go like this. What is R? What is this small r? Apply Snell's law. For example, this is having the refractive index of 1.5. Or forget. Simply understood. Path. They are asking simply path. Complete the path of light. Understood?
Yes, sir.
Why is it not why TIR? There is no TIR because light is striking at an angle of incidence that is less than critical angle. Understood?
Yes, sir.
Now one more question I am asking. You just give me the answer. Okay. Draw the figure. This is the last question. Okay. Now light is coming like this. Normal incidence. Clear?
Yes, sir.
And this is 60-degree angle. 32 degree. 30 degree. 90. And critical angle is 42 degree. Clear?
Sir, in the previous question, R will be inverse sine 7.5, sir.
Yeah, whatever else. Inverse. Because mu is not given, na. I just give 1.5.
Yes, sir.
Okay, nice. Like, very nice. You can solve like for mu into sine 30 equal to 1 into sine r. Then r will be sine 30, na. Sine 30 is half mu by
1 by
2
2.
sine r. Then r will be sine inverse of mu by 2. Clear? I
Yes,
didn't
sir.
solve. Now see this question. What is the angle of incidence? Here.
0.
Very nice. Then it will go straight. There is no angle of refraction. It will go straight like this. Clear? Now
Yes,
draw the
sir.
normal here. Draw the normal. Normal means whenever I am saying normal, normal means it is 90 degree to the surface. Clear?
Yes, sir.
Now tell me if this is 90, this is 90, this is 90. If this is 60, clear? Then how much this? This is also 90. This is 30. Then how much this?
60.
Very nice. This is 60. Check. It is more than, less than. Critical angle is 42.
Less than.
Angle of
TIR will not.
angle of incidence is more than critical angle, less than.
Less than critical angle.
Again, you are saying wrong. See, this is the
Oh,
incident
yes,
ray.
more than
This is
critical
the
angle.
incident ray. It is striking. What is the angle between normal and the incident ray?
60.
This is na. Why are you looking this angle? It is not. This is our normal. This is the incident ray. Then angle is this. Clear? 60 degree.
Yes, sir.
It is more than critical angle. Then again TIR. Clear? Here how
Yes,
much
sir.
angle? This is 60. This is also 60. Then again you will draw the normal. Clear? Now tell me.
Yes.
This is 60. This is also 60. If this is 60, this is 30. This is 30. This is 90. This is 60. If this is 60, this is 30. Now this is normal. Now see, what is the angle between incident ray and the normal?
60.
Tell me, what is the angle between incident ray and the normal?
30 degrees.
30 degrees. See, this is the incident ray that is striking the surface. And this is the normal. Clear? What is the
Yes, sir.
angle? 30 degree. Is this 30 is more than critical angle or less than critical angle?
Less than critical angle.
Then there is no TIR. It is going like this. Understood?
Yes, sir.
Clear? Any problem?
Yes, sir.
Any doubt?
Yes, sir.
It will take time, okay?
Yes,
It's not a easy topic like, clear?
yes, sir.
So this topic ended like refraction, TIR. It's highly important topic. So in this topic, simply you should understand the condition for TIR is it should go from denser to rarer. Next condition is the angle of incidence is more than the critical angle. Now what is angle of incidence? Again I am telling. See the boundary. Whenever you see any boundary, when light is oblique incidence, like if light is striking like this, then always draw normal. At this point light is striking, that is point of incidence. You will draw the normal. Then this is the angle of incidence, the angle made by the incident ray from the normal, clear? Like this. This is the angle of incidence. This is not the angle of incidence. This is the angle made by the incident ray from this boundary. This is boundary. Clear? This angle is known as glancing angle. This is glancing. Already have discussed. Glancing. This is not the angle of incidence. Okay?
Yes, sir.
Never ever say, because boundary. This is the angle made from the boundary. But this is the angle made from the normal. This is normal. At 90 degree. Clear? So this is angle of incidence. Understood?
Yes, sir.
Any problem, any doubt?
No, sir.
Revise the lecture again, okay?
Yes, sir.
I think no doubts
Sir,
will be.
yesterday I tried to open the document and I wanted to revise, sir, but I was not able to open, sir.
No problem, okay? Which document?
Where all the recorded sessions are.
You are not able to open? Just show me your screen.
It has to download like from 3 hours or something like that also.
No need to download. Okay, it will. First of all, no need to download. How much you will download? Just watch the video directly.
It never used to be like that, but suddenly it happened.
Okay, try to open in your laptop. Okay. Okay, understood like today's lecture. Any doubt?
No doubt, sir.
Revise. Okay. Tomorrow I will start
Yes,
lens theory. After lens, one topic is prism. Then this topic is light reflection, refraction completed. Then we will start electricity. Clear? I
yes,
will not teach that topic till now because it's a very easy topic. I will teach that topic later. Defects in eyes and
yes, sir.
eye functioning, like what is the function of cornea, pupil, those things that we will take later. That is not that much importance. Clear? So we will take in some other classes. That is those topics which are not very important, very theory based question. Then we will discuss it later. Now these topics, whatever I have discussed, highly important. Too much weightage in class 12, around in IIT JEE NEET, 60% weightage from this topic. Understood? So
Yes,
work
sir.
hard, and I am really happy. Like I see your progress in the yesterday questions. Like I also checked, like around three questions are right. Last two question little bit calculation problem, but if you judge, if you don't solve directly, blindly don't solve any question. Always draw the diagram in ray optics. In ray optics, always draw the ray diagram first. If you have mastery in ray diagram, then how am I solving? I don't know like where is V, where is U. I know the concept only. Conceptual clarity is very important. If you have, you can solve any question, whatever tough question it is. Yeah. So work hard, and I think you are doing. Such questions are very tough, really. But you try well. It is really nice. Revise the lecture and solve as many as question possible. Yeah.
Yes, sir.
You can't. I can't say like from where I take this question. It's really good standard book. I can't tell because it's something confidential, and
Yes, sir.
I can't disclose. Really, I'm really sorry currently. Otherwise, you will.
Sir, but I have a guess, sir. H.C.
uh,
Verma, sir.
huh?
H.C. Verma.
Oh, how do you know?
I have it, sir.
You have. Okay, I will change now.
But
You have S.C. Verma. Actually, I'm having S.C. Verma. Always follow this book. See, S.C. Verma. Old edition. You have new edition. I'm having
yes,
the
sir. New.
old. This is really nice book. So I used to follow this. Yeah. Really tough theory, but it's really nice theory. It is given in that.
Yes, sir.
Clear? Any doubt? No problem. No problem. No problem. I am having lot of books. Work hard. Clear? Okay, I will
Yes, sir.
upload now. Okay, good night. Take care. Bye.
Good night. Bye.